Okay, you are going to learn new, still the same chapter, input and output interfacing, but this time we're going to look at more complex input. So this time we're going to see metric keypad or keypad. I think this one you already have some kind of experience from lab, I think lab number 3, keypad. So today we're going to look at very closely uh, on the basic operation, how to interface as described by this learning outcome. So after you have finished this topic, this particular subtopic, you should be able to explain the basic operation of keypad, the characteristic of keypad, the type of keypad, and so on. So you should be able to do that. And then after that, you should be able to describe the key press and detection mechanism for keypad. How does the keypad pressing button function? How does it detect whenever the user start pressing certain character? So you should be able to understand that. And then you will learn how to interface the keypad with this PIC 16F 877A, and then the last one, you should be able to write a C program to manipulate the keypad. What happens when you press certain key, what happens, what the output should be, and how to display the output according to the input from keypad. So basically, you should be able to do that. So we look at first the intro part. So what you see here, the figure is some type of keypad. Okay, so this is what you see here is 3 by 4 keypad. Same goes for the bottom one. Okay. But the appearance, okay, so what you can see here, the appearance here is much more complex than this one. Okay, pleasant than this one. So there are many type of keypad available. So basically, keypad is an I/O device, input/output device. So when you connected the keypad to the microcontroller, so whenever the user or the programmer press the keypad, so they can use keypad to enter certain command or certain input that the microcontroller can understand, can read, and also from there it will start to process certain action related to key, which key being pressed. So it is a form of simple data entry. Only numerical, and then sometimes if we see larger metric, for example 4x4, there are also some alphabet, but very limited the alphabet, mostly related to the numerical. And this one, these two figures here, the first one would be the internal connection of a 4x4 keypad. We have 4 columns, 1, 2, 3, 4, and then we have 4 rows. So that's why we call it 4x4. And then if you refer to the next figure, so this is an internal structure. What is building, what is composed inside the keypad. So basically, contain multiple number of push button. So the arrangement you can see here. Okay, so we have row, we have column, and then between column and row, we have one keypad. And then the following one, second column, same goes for the similar row, another keypad, another push button, and then another push button, and so on. So the arrangement for various type of keypad, the arrangement is similar. It's something that looks like this. Push button will be connected between column and also row. Then so you can see here. Okay, so whenever the user press specific button, let's say SW2, so this means that column 2 and row 1 will be connected. Okay, so that one will be discussed very detailed later on. Okay, so basically, when we look between column and row, there will be no connection, okay, unless the push button is being pressed. Okay, so when the user press, the column and the row will be connected, okay, by the switch button. If the switch button is being released, so there will be no connection. Okay. Definitely, uh, definitely independent. It's separate. And for example, if we press key 3, so you can see from here, 1, 2, 3. So the key 3 should be located here. Okay. If you press key 3, so this means that only column 3 and row 1 will be connected. Other than that, remain unconnected. Only these two, column 3 and row 1. And then this is what you can expect whenever the flow, whenever the switch button, whenever the push button being pressed. So basically what you see here. Okay. So this means that column 1 and row 1. So this one column 2, this one column 3, row 2. Okay. So the flow. Any connection, so you can see indicated by the red color. So this means that the column and the row is connected. So there are two types of programming to interface with a keypad. So the first one, key press detection. This is a method where we use it to detect position of the key being pressed. Okay? The first process, and then after the first process completed, you go for the second one, the identification of key coming from the first process. So if you refer to the first process, so you can see here, the detection can happen in two methods, the interrupt method and then the scanning method. The interrupt method will not be covered, but however, if you come, let's say during the week 9 or 10 or 11, you will learn interrupt chapter. That one will be complete, okay? But without focusing, without focusing on the keypad detection, but just the whole topic related to the interrupt only. So for this topic, for this chapter, you're going to learn scanning method. Only this method will be covered. So how does the scanning process happen? So basically, first you need to connect directly to the microcontroller. So scanning means that the program going to scan by checking all line by one by one. So this means that if we have 4 rows, if we go checking row 1, then column 1, row 1, column 2, 3, 4, and then going down to column 2, and then repeat again column 1, 2, 3, 4, and so on. So the process, the flow start from row 1, then check for column, and then go for row 2, check for column, and then you repeat again. You repeat the whole thing. So for the scanning, so the scanning, we make row line high or lower, one by one, and then you read the column. So basically, you can either set low or high. Okay, so, but basically, throughout this lecture, the logic, logic going to see will be low. The scanning process will happen during low only. Okay, and then after that, when you pass low to the row, then you read the content for each of the respective column connected to that particular row. Okay, so for example, each row is set low in turn, and then state or input is tested. If no button is pressed, then all the input should be high. Okay. First you set entire row is low, and then when a key operated, a low on that row is detected on the column input for that particular key. If no column being pressed, it will give out high to the column. If either one, if certain character being pressed, so this means that that particular column will be low. So this means that you can from the scanning you try to identify which is the low coming from. So this is a binary of ASCII code or simply the key location. So whenever the program detect which location the key, the push button or the switch button or the keypad button be pressed, so it will return a number. So this means okay, so the number will be just a location only, okay, just a location, and then after that maybe proceed to translation of key, translation of process, function, and so on, depending on certain application. Okay, so other than that, you can also reverse okay, by making the column line high or low, and then read the row to detect which one is pressed. So the flow can be opposite. Okay, you can either transmit to row, read column, or you can transmit to column and read row. The flow is free. Okay, so you can see here, this is the flow chart for scanning method. So you can see very detailed. So this is a flow chart. So I think you should not have any problem. Okay, so whenever you are dealing with flow chart for C programming, make sure that you make sure okay, that this is an oval. Okay. So you should be familiar okay, with the basic shape of the flow chart. So make sure whenever you want to start your flow chart or end your flow chart, make sure that the shape is oval. And then after that, the rectangular we reserve it for process, okay, for process or function. And then this diamond shape here to indicate decision making. Okay, what happens if the condition is true? What happens if the condition is false? Only two output okay, from this decision making, true or false, yes or no. That's it. Okay. And then after that, so you can see the arrangement from this shape. So you can see from start and then to end. Okay. We reserve it for oval, and then after that for process, rectangle, and then this one is shape making. So this is the flowchart. So I will start explaining how does the scanning process start. So you can see from here, we go first by starting the program, and then we set all the row equal to 1. Okay, so for example, it cannot, right? So try to understand first. I will explain. Okay. So let's say if we have taking less complex keypad matrix, let's say 2 by 2 or 3 by 3. So this means that we set all the row. If the row is 4 by 4, the row of the row must be set as equal to 1. And then after that, after you have set all the row equal to 1, you go to the first row and then you set it to 0. Okay, the first row. Okay. The second, the third, the fourth, the fifth, and so on, you leave it as 1. And then you go for the decision making. Okay, you start scanning column by column that is connected to the first row. Okay, so check. You check. Column 1 equal to 0. If no, right now we consider nothing. No key being pressed. So we consider nothing. Nothing happened. So you can see if column 1 not pressed, go to column 2. Condition. Okay. Check. If column 2 not being pressed, means the answer would be no. Check for column 3. If column 3 not being pressed, check for column 4. Okay. And then if you have another column connected, so you go for the 4th, 5th, 6th, and so on. okay, depending on the total number of columns connected to that particular row. Okay, so for the example, only 4. So you go checking from the first column, go to the second, third, fourth. Okay, provided that the output is 0. Okay, output is 0, so the condition is not true. Okay, the condition is not true. So this means that the push button from column 1 not being pressed, okay, nothing, not connected. You go to column 2, still not being pushed, go to 3, and then go to the 4. Okay, and then okay, once you have reached to the final column, you reset again, set the row 1. Okay, so the last time row 1 equal to 0, so you set again back to 1, and then you go to the following row, the second row, you set to 0. So do the same thing, you repeat the whole process. Okay. Any column that is connected to the row 2, okay, you check one by one. Okay. So you go for column 1, condition not true, go to column 2, not true, go to 3, not true, still not true, go to 4. Okay, and then you reset row 2. Last time row 2 equal to 0. So right now, after scanning all the column connected to row 2, you go to row 2, you set it again to 1. And then you go to the following row, which is row number 3, you set it to 0. And then start checking each column connected to row 3. If the condition or the column, the condition result in not true or false, you go to the fourth row. Okay, do the same thing. Okay, column row 3, you set to 1, and then you go to the following row, the fourth row, you set it to 0. Okay, do the same thing. Repeat the whole process. Check for each column. Okay, and then after that, is still no key be pressed. So this means that you repeat the whole process. You repeat the whole process. Go back to row 1. Okay, so let's say, for example, column, we have column 3. Column 3, row number 2. Okay, so the flow would be the same. Okay, start first from row 1, check column 2, check column 1, check column 2, 3, 4, nothing. Not true. You reset row 1 to 1, and then you go for the following row number 2. Okay, you check again. You check again, start from column 1, column 2. Okay, let's say that column 3 being pressed, so this means that the condition is true, not false. So what happens is that the location from column 3 will be returned, okay, return to the function, okay, to the function, and then the progress will stop there, okay, because this one only related to key scanning, okay, and not key identification, only for key scanning. So basically, the key scanning, it will just return any value, location, location that the key being pressed. So you can see from here, okay, location here is not directly represent the key number. So you can see from here, okay, location 1, location 2, location 3, location 4, and then location 5, location 6, location 7, location 8. Location 1 will be number 1. Location 2 will be number 2. Location 3 will be 3. But location 4 is not actually number 4. Okay, why? You can refer back to this one. Okay, so this is location 1, location 2, location 3, location 4. So location 4 is actually for input A. Okay, input A, and then you go for location 5, location 6, location 7, location 8. So location 8 will return the value, the character that you press input is actually character B. Okay, so it is not giving the actual value of the keypad. Okay, only the location number. Only the location number. Where is that particular key coming from? Okay, so that is the purpose of scanning method. Okay, so this one would be the same, similar to my explanation. You set the row first to 0, only one row, one row you set to 0, and then you check for each column connected to that particular row. If nothing happen, you move on. Okay, you move on to the following row. Okay, so this one will be the same. Okay, so for example okay, for example, if the return location value is 4, okay, so I start from the top one. Okay, so based from the return location, okay, not the actual keypad value. So you can see, okay, sometimes as you can see here, there are many type of keypad. Sometimes the value here is A, sometimes the arrow here is up, down, left, right, and so on. Okay, sometimes, so you can see here, the value is different. Okay, other than number, there are also specific function that is different, okay, from the previous model and so on. So basically, the scanning method is still the same. Okay? If you are using for keypad 1, keypad 2, keypad 3, the scanning method would be the same. So same meaning that if the user pressing certain character, it will return only location, location value from the scanning process. And then after that, you go for key identification. Okay? You try to compare, okay, the location that come from the keypad value. So for example, if the return value is at 4, so this means that the location is 4, not number 4. Okay? Location is 4. If you refer to keypad 1, so 1, 2, 3, 4. Okay? Keypad 2 means that 1, 2, 3, 4. Arrow up. Keypad 3, 1, 2, 3, 4. Escape. Okay? So if you refer to keypad 1, so this means that it is actually key A being pressed. Okay? If you refer keypad 2, arrow up being pressed. If you refer to keypad 3, only escape button being pressed. So the value is not the same, okay? But the method always similar. Okay? No matter what type of the keypad shown here. Okay? Provided that the scanning, if you are using 3 by 3, make sure that the scanning is written for 3 by 3. Okay? If you are using 4 by 4 matrix, make sure that the function it can accommodate up to 4 by 4. That one you need to make adjustment according to the number of matrix that the keypad you want to use. Okay, so this is general connection for PTK40A. This one will be the kit that you're going to use when you return back after the second semester break. For the first semester break, the second half of the semester. So this is the connection that you need to familiar, you need to know. Okay, the one that being used, the schematic, the pin type that we use in PTK40A. So this is the keypad. So you can see 4 by 4 keypad. So the last column, A, B, C, D, and then the last row, we have asterisk, 0, hash, and then letter D. And then what you see here, okay, the first four pin here, C1, C2, C3, C4 would be the column. And then the last four pin here would be the row. Okay, so the name would be C1 for column 1, C2 for column 2, and so on. The last column would be C4. Same goes for row. The first row will be R1, and then row 2, row 3, and then the last one would be R4. So the connection would be that R1 is connected to RD4, R2 connected to RD5, R3, RD6, and then this one RD7. Okay. This one apply for PTK40A only. If you're using, you want to do it by yourself, okay, or you want to simulate, you are free to use any free port that you want to use, would you want to connect. Okay. But for PTK 40A, this is fixed already. Condition is already fixed. And then looking at the column side, so KC1 will be connected to RB0, port B, B pin 0, and then C2, C3, and then C4 going to the following RB1, RB1, RB2, and then RB3. So the connection would be something like this. Okay. For row, directly connected to microcontroller, but for column, you need to put register, register, okay, register. And this one, KC1, KC2, KC3 is the switch one, switch 1, switch 2, and then switch 3. This is for schematic, okay, for the keypad using in K48. So the keypad pin need to be pulled up or pulled down to avoid floating access. Pulled up normally, you need to connect this one. You need to connect this one with 5 volt. Okay. If you want to use pull down, so this means that this one you need to replace it with ground. Ground. So we go to the next one. Okay. So we know okay, for PTK 40A, the connection will be that 4 bit connect to port B, and then the remaining 4 bit, another 4 bit, okay, from this one, from the whole 1 byte connected to the port D. So the arrangement would be that column, we connect that to port D, starting from RB7 to RB4, one, okay, and then for column, we reserve that for RB0 to RB3. Okay. And then the debounce effect also exists for keypad. So that whenever you want to write your program, you consider the debounce effect. Okay. You need to delay, put some delay between keypad pressing, okay, just like switch button, okay, because of the debounce effect. So basically step, okay, just like I mentioned, okay, so this means, so for this part, we're going to see how does the program function. So basically, we all know, start by firstly, you need to set all the row equal to 1, and then you go to row 1, you set it to 0, and then from here, you observe, okay, you detect any key press connected to that particular row, column 1, column 2, column 3, column 4. And then the code will be, you need to use if statement, if statement. If statement column 1 equal to 0, so this means that this one, okay, return 0, return 1. So this means that this is the location, okay, 1, 2, 3, 4, okay, location 1, 2, 3, 4. Okay, so if column 1 is true, okay, equal to 0, double equal should equal to 0. So this means that button 1 being pressed, so the program must return 1. Okay. If not true, proceed to checking column 2, okay. And if nothing happen, go checking column 3, and then go checking column 4. So the process repeat for the following row. This one, you put 1 again, and this one you put 0. And you check okay, using the same similar code, but the return value need to be changed. Okay, why? Because the first one will be 1, 2, 3, 4, and then the second row will be 5, 6, 7, and 8. Okay, the return value must be changed accordingly. Yeah, and then this is the subroutine or function for keypad scanning process. So the name is read keypad. Okay. You can put any name. Any name you want, just as long as you understand the name, and then you can call the name correctly. Yeah? So make sure that if the name here is starting with capital R, make sure when you call, you follow the similar syntax. And then the routine, the function, there is as char character. the positive number only. Okay, so you go this one. Okay, this one between the subroutine. Okay, you have open and close curly bracket. This one to indicate that anything written after open and closing curly bracket will be inside this subroutine. Okay, you go first by declaring a new variable. This one called UC underscore number. Set it the initial value equal to 0. Okay, so the type will be char, still similar. Okay, char because the number is not more than 255. Okay, so positive number. So this means that the value that the UC number can store, okay, coming from this one. Coming from this one, so you can see the number is the highest number is 16. Mean that no need to put int, no need to put long. Okay, you just put it as, declare it as char would be sufficient. And then the code, okay, the code start by making row 1 equal to 0. Okay, the rest, row 2, row 3, row 4 set to 1. This one you can also do before you call the function. First, during the main, during the initialization, you can also set. You can also set this one, set or row equal to 1. Okay, you can set it before the subroutine. Okay, before the subroutine, and then after that, you just concentrate on setting row 1 equal to 0. Okay, the rest you set it as 1. Okay, depending on how many metric. If you are using 3 by 3, so no need for R4. Okay, no need for R4. Okay, this one only for 4 by 4. Okay, so if you are set this one, you set to 0, and then the rest you set to 1. Okay, wait for 30 microseconds. So you can see here, okay, a delay. Okay, a delay, and then you check every respective column connected to this row. We have column 1, column 2, column 3, column 4. One, column 1, column 3, column 1, 2, 3, and then 4. You check, okay, you check using if statement. This one, double equal to, if KP C1, this one, okay, KP C1, okay, this one, keypad for C1, keypad for C1. This one is just a name. Okay, you can put any name you want, okay, but make sure that you declare first. Okay, so the name here has been declared, okay, on the top section of this program. So right now you just make sure that you are using the same declaration name. So the name declare is KP underscore R1 for row 1, and then KP underscore R2 for row 2, and the last one KP underscore R4 for row 4. So make sure you are using the same name, okay, the same name and then the same format. So you go, you set first row 1 equal to 0, and then you check. If the condition is true, you return the location number. Okay. Location number will be first, second, third, and then the fourth. Okay. You go checking one by one. Okay. Check first, column 1, nothing happened. Go to column 2, nothing happened. Go to column 3, nothing happened. Go to column 4. Okay. If still nothing happened, you proceed to. Okay. So previously row 1 equal to 0. So the second one you set. This time you set row 1, row 2 equal to 0. Okay, but row 1 you put 1. Okay, then do the same thing. Okay, do the same thing, but the return number, okay, the return number, okay, already different. Okay, because this one, okay, refer to this one. Okay, 1, 2, 3, 4, and then 5, 6, 7, and 8 refer to row 2. Okay, refer to row 2. So that's why the return number here is 5, 6, 7, 8. And then for row 3, do the same thing. Okay, but the return number will be different. 8, 9, 10, 11, 12. So the return number will be different again. Okay, and then you do that up to the final row. So you can see here the return number here is 16. And then you can see here, okay, every column, when the condition is true, we put the return value into this variable, okay, into the variable UC. And then after that, when you have complete, you return the number of the variable here, the number inside the UC number variable, okay, provided that the key being pressed. If the key is not being pressed, so return nothing, because nothing being pressed. So that's that one. We conclude the scanning process of the read keypad. So we look at example first. Write a program in C language to read the key press on the metric keypad and perform the task as stated in table here, table below here. So we are using 4x4, 4x4, and then for character coming from the key, character 0, 1, 2, 3, 4, and then last one 6. What happens if the user press this character? It will display the microcontroller, the program will display the number on the 7 segment. Okay. If the user press 1, so this means that the 7 segment will give up 1, okay, to the 7 segment. If the user press 5, so this means that the 7 segment will display number 5. Okay. Only from 0 to 6. Okay. But for 7, 8, 9, display the number value, but blink it X time, okay, with 3 millisecond delay, okay, for each respective display. Okay. So X will be the value that of that pressing number. Okay. If the value is 7, so this means that it will blink 7 times. If the value is 8, it will blink 8 times. And then if the user press A or star, this will turn on all the segments. So pressing B will blink the 7 segment display 5 times with 300 millisecond delay. Then lastly, pressing C, character C, and then hash will turn off all the segments. So this is the connection. This one, if you are using PTK48. If you want to use Pixel Lab, you can also use similar connection. You can also use other type of connection. If you want, you can also connect the whole pin to port D, the whole pin to port B, to port C. Okay. It is possible. Okay. Provided that you know, you need to declare. Okay. Okay. The row must be set as output, while the column must be set as input. So this is the connection for 7 segment. Okay. This one, RC starting from RC0 and then RC6. Okay. So the type will be 85. Okay. So we can see from here. First, you declare first. Okay. This is the name. KP underscore R1. You define RD4, the name as KP underscore R1. So the next time when you call it, you can call KP underscore R1. So this means that KP underscore R1 would be representing port D pin number 4. Okay. Same goes for the rest. Okay. This one you set as output, and then this one you set as input. If you are using the whole port D, make sure that you assign this correctly. Okay. You need to be aware where is the output, where is the input. Okay. But better for beginners level, try to follow the example shown here. And then after that, define seg7 located at port C. So it means that you are defining the whole port C, okay, as seg7, not individual. So this one, so representing the whole port C. And then after that, you define array pattern here. This one will display 7 segment pattern from 0 up to 9. 0 up to 9 for the 7 segment. So you can see the array number will be 9, array size. And then the type will be char. So it means that from 0 to 55, and then constant number. So this means that the value remain constant throughout the program, and then assign positive number only. This one you use it to display character from the 7 segment, and then this one char KP pattern. This one refer to the keypad pattern. So keypad pattern is that number 1, number 2, number 3, A, number 4, number 5, number 6, B, and so on. Star hash and so on. This one to represent the character or the character coming from the keypad. And then you go to the main subroutine. This is the part you set which one belong to output, which one belong to input. So for output, we are using port D, so we just set the whole port D as output by setting 3D equal to 0. Provided that the remaining port D is free. You are not using any available pin to connect other device. You are only reserve port D as output only. So the rest remain free, so you can use this type of declaration. And then for 3B, since we are using the first 4-bit, the first 4-bit as input, so you can see here, they set the first 4-bit as input. And the rest, you can set it as output. And then for 3C, for this one, you set it as output. So 3C, you are using it to connect to 7 segment. And then declare, introduce a variable, char type, positive number unsigned. You call it KP underscore num. Then another variable, this one int, integer. The name is I. And then KP, this one, the variable here is equal to the read keypad function. Keypad function coming from where? Read keypad function coming from this one. Any value written by this function will be stored in kp underscore num. If the location number is 15, so kp underscore num is equal to 15. Depend on the return number. So the first code will be if statement. If kp underscore num greater than 0, so mean that you can see if there are no negative value, if we are pressing from 1, 2, 3, 4, A, B, C, D, 5, 6, 7, 8 to 0, 9. So only positive number. So this means that if kp is positive number greater than 0, and then you check again. Once the number is positive, you check again. If kp num double equal is equal to 9, or kp num equal to 10, or kp num equal to 7. This one you are checking the location and not the keypad value, not the character value. The keypad location. The keypad location would be location 1, location 2, location 3, location 4, location 5. Not the value here, not the value 1, not value 2, not value 3, not value A. You are not comparing with the value, you are comparing with the location only. So you compare with the location if and then or. If either one is true, so the statement here will become true. Not and. If either one is true, either one means that the number can be either, the return number can be either 9, 10, or 7. So if either one, 7 location, 7, 8, 9 being pressed, so the statement will become true. So you go for another looping. You implement for looping. So this means that starting from I, the initial value of I equal to 0. So we already declare I. What is I value? I value is int, integer. So this means that the number can count up to more than 255. More than 255, but not less than, not more than 65,500 and something, 16 bit. So I is less than KP pattern, KP num. Okay. So if I value is less than the number returned by KP num, okay, you start display the number, this one, okay, segment pattern according to the index number coming from KP num, and then you move it to port C. Wait for 300 millisecond, and then you turn off. Okay, this one for blinking. Off, wait another 300 seconds, and then you repeat. You repeat by increasing the value, provided that the parameter here is true. If the parameter here is false, not true, you go for the another if statement, this one coming from the same. Okay, so for coming from here, okay, if coming from if, so you continue from the if you need to start with else if. If another you want to produce another if, you go for is else if. Then if you have another, you go for else if. Okay, and so on. Okay, how many if there are 4 if, so the first one must be if, and then the rest will be else if. Okay, so if the condition here is not true, or the key here is not true, okay, you go for the second if, else if. This one you need to compare key location 4 or key location 13. Okay, key location 4 and 13. 4 would be A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this means that A and star, or A and star, one, it will turn on all segments. So A and star, one, A and star. So port C, you want to turn all, you want to turn all the segments starting from A, data pin A, B, C, this one. A, B, C, D, E, F, G. You want to turn all the segment. Okay, so this means that you need to send character 8. That character 8. So the pattern, the index number must be 8. Okay, so the number here, you need to send it to array sec 7 pattern. So the value here need to transfer to port C. And then after that, another else if check another key. This time 8. 8 would be here B. B means that here it blink the segment. Blink the segment 5 times. Okay, 5 times. Okay, 5 times blinking. Okay, still the same. Pattern 8. Okay, on, off, wait for 300 milliseconds. Then off, wait for 300 milliseconds. Repeat again. Okay, provided that the parameter is true. And then after that, you check again. Okay, you are using another else if. KP num key location 12 and 15. 12 and 15, 4, 6, 4, 8, 12. C, yeah. Okay. C, and then C and hash. C and hash. So C and hash will mean that you turn off all the segment. So for turn off all the segment. For C, you set it to 0. Just port C, yeah. Not the array, not the array pattern. It only port C. So you set the whole port as low. If you put it too low, okay, by giving out value 0. So 0 means that you're putting low for the whole port. Bit 1, bit 2, bit 3 up to bit 8. And then if other keys than the one we use, then you want to use, you just show the value only according to the number of pipette. So this means that you are referring to the 0, 1, 2, 3, and then 5, 6. 5, 6. Okay, so that one will be the conclusion for 7 segments. So we try to do some kind of simulation. This one. Okay. So this is the program for keypad. For keypad that you see here. This one. Okay. So make sure that you put the initial section first. Okay, the configuration setting, the clock setting. I'm using 20 megahertz. 20 megahertz. This one you need to declare. Okay, this one you just follow from the example program. Okay, so the rest will be the same. Okay, except that you need to do the first one, the first section here. The setting and then the clock frequency. Other than that, nothing. And then for the peak sim, okay, the setting will be the same. Okay, so properties. Okay. You need to follow the column here connect to the column connected to port B, the row here connected to port D. And then this one connect to port C. Okay, the whole port starting from RC0 to RC6. Okay, decimal point not connected, and then so you can see here D1. Okay, I'm not putting any RE1. Okay, so you can see based from previous example from laboratory exercise, so you can see RE0, RE1. But this one, I just connect to positive 5 volt. So this means that the first segment will be continuously turned on. Okay, that's it. If I want to connect to RE0, for example, so this means that I need to include RE0 as a part from the program. So you check first, Fixing Lab, and then compiler, then PIC, nothing unfamiliar, unusual, you go for building the program. Okay, wait until build success, and then you can go for debug. Okay, you can go for debug main project. So you can see here nothing, no peak sim, no peak sim tab. So need to wait. Wait, if the process is successful, peak sim will appear here. Okay, peak sim appear from out. Okay, 1, 2, 3, 4, 5, 6. A, stay 8, A and star, and then 7. 7 means that blinking 7 time. Okay, you can count by yourself. Okay, 7 time, and then hash. Hash will be turning off the 7 segment. Same goes for C, and then what happened for D? Nothing. This one B. Zero will be shown 0, 1. Same goes for 1, 2, 3, 6, okay. 8 blinking. 8 time. 9 also blink 9 time. Okay, want to delete. Okay. A will be turning on all the 7 segments. Think A and star strict. Okay, so that one we conclude explanation for chapter input and output, okay, related to keypad. So after semester break, we will look at another input and output interfacing, which is LCD. Okay, so maybe on Friday, this Friday, you are going to do the last module, module number 4, and that one related to LCD. Okay, so you're going to do lab first, and then the theoretical part, the lecture part, you're going to do another week after that, okay, during lecture. Then make sure you prepare, you read, you prepare, you study, you do revision, because after semester break, you will sit for test. Okay, test 1. So test 1 will be face to face. Okay, make sure that you study first. Okay, and then you do the tutorial if you are not confident with your answer, you can always contact me, but make sure that you do first. Okay, show me your answer, then I can guide you.